Hi students, I'll try in this educational video to technologically introduce the steel tension member resistance as the ultimate limit state criterion associated to tensile. Of course, as simply and as clearly as possible. Okay, let's go. Well, based on the Eurocode 3 standards associated to the European Standards 1993, the ultimate limit state criterion associated to tensile is expressed as NTED, which is the design tensile force, divided by NTRD, which is the design tensile resistance, is lower than 1. This simply means that the design tensile force applied on the steel tension member should not exceed the design tensile resistance of the steel tension member. For the design tensile force NTED, it can be simply seen as the maximum normal force applied on the tension member, while the design tensile resistance NTRD is obtained as the lesser of NPLRD and NURD. NPLRD characterizes the yielding of the gross cross-section, and NURD characterizes the ultimate failure of the net cross-section. NPLRD is determined as the gross cross-section A multiplied by the yield strength Fy divided by gamma M0. Gamma M0 is equal to 1. And NURD is determined as 0.9 multiplied by the net cross-section A net multiplied by the ultimate limit strength Fu divided by gamma M2, which is gamma M2 is equal to 1.25. The gross cross-section A characterizes the failure mode related to MPLRD as it is depicted by the figure that you see now in the left of this slide, and the net cross-section A net characterizes the failure mode related to NURD as it is depicted by the figure or the picture that you see now in the right of this slide. Now I'll try to explain how to determine the net cross-section area. In the case when the steel tension member is connected using a non-staggered fasteners as it is depicted by the figure that you see in the left of this slide, the net cross-section area A net is determined as the gross cross-sectional area minus the sum along a perpendicular direction to the tensile force direction of the bolt hole diameter multiplied by the thickness of the steel tension member. In the case when the steel tension member is connected using a staggered fasteners as it is depicted by the figure that you see in the right of this slide, the net cross-section area A net is determined as the greater of the sum along a perpendicular direction to the tensile force direction of the bolt hole diameter multiplied by the thickness of the steel tension member, and the steel tension member T multiplied by the quantity number of holes multiplied by the bolt hole diameter minus the sum along a zigzag direction of the square of the spacing along the tensile direction, the spacing here between the bolt hole diameter divided by 4 times the spacing along the perpendicular direction to the tensile direction. Pay attention, when the holes are not located in the same plane, the spacing along the perpendicular direction to the tensile direction denoted by P is determined as it is depicted by the figure that you see now in this slide. Well, it's to note that some specific rules should be taken into consideration in the case of steel tension angle member. In the case of single angle in tension connected by a single row of bolts in one leg as it is depicted by the figure that you see in the left of this slide, the ultimate failure of the net cross-section denoted by NURD is determined as the effective net cross-section area denoted by A net effective multiplied by the ultimate limit strength Fu divided by gamma M2. Gamma M2 is equal to 1.25. The effective net cross-section area is determined by the table that you see now in this slide, depending on the number of bolts. And as you can notice, we have coefficients beta 2 and beta 3, which are determined based on the table that you see in the bottom of this slide, depending on the pitch and the bolt hole diameter. And in the case of an equal angle welded by its large edge, the effective cross-section area is considered equal to the gross cross-section area. That's all for this educational video. If you have any remarks, suggestions, or questions, please mention it in the comments. Thank you very much for your attention.